Yesterday we have seen some sums on root locus. Today we are going to see more sums on root locus. Then we are going to see design of control system using root locus. Plot the root locus for a unity feedback system. Unity feedback system whose open loop transfer function is g of s equal to 1 upon s multiplied by s plus 4, s square plus 2s plus 2. First we have to find to draw the root locus, first we have to find the poles, open loop poles. Open loop poles are 0, minus 4, minus 1, plus or minus j. These are the poles. Zeros, nil. Therefore, n equal to 4, n equal to 5, 4, 4, 4, m equal to 0. Therefore, number of root locus branches equal to 4. All 4 branches end at infinity. All 4 branches end at infinity. Therefore, we have to find the angle of asymptotes. We have to find phi a equal to 2q plus 1 plus or minus 2q plus 4 multiplied by 180 divided by n minus m. That is equal to, for q equal to 0, 1, 2, 3. Because 4 branches end at infinity. When q equal to 0 and m equal to 4, n minus m equal to 4, 180 divided by 4 equal to 45. That is equal to 45. Am I correct? 45, then 135, then 225, then 3, then 3 means 7 times 280 plus 35, 315. So these are the angles at which the asymptotes will approach the infinity. Sigma A equal to sigma A centroid equal to sum of real parts of poles minus sum of real parts of zeros divided by n minus m. That is equal to sum of real parts of pole equal to minus 6, minus 6, minus 0, minus of 0 divided by 4. That is how much? 3 by 2. Minus 3 by 2 or minus 1.5. The poles are one pole at 0 origin. This is minus 1, minus 2, minus 3, and minus 4. So, minus 4, These are the poles. This is part of root locus. Because any point between 0 and -4 is part of root locus, because to its right odd number of poles. But this moves towards the right, this moves towards left. Therefore, definitely there will be a breakaway point. There will be a breakaway point. We have to find the breakaway point. dk by ds, we have to find k equal to what? K equal to minus s multiplied by s plus 4 multiplied by s square plus 2s plus 2. K equal to, because how we got 1 plus g of s equal to 0. That is characteristic equation. From this, we can find this s power 4 plus 6s cube plus 10s square plus 8s equal to 0. This is k. Sorry, this is k. dk by ds equal to 4s cube plus 18s square plus 20s plus 8. Find the roots. So the roots are minus 3.1 and minus 0.7 plus or minus 0.3j. Only one real root. Only one real root. Other two are complex roots. That too, minus 3.1 is on the root locus. Therefore, breakaway point is this. This is the breakaway point. This is the breakaway point. Minus 3.1 is breakaway point. Minus 3.1 is the breakaway point. What are the angle of asymptotes and sigma a minus 1.5? Here. From here, 1.5. Here also, if we select 1.5, I can draw the angle of asymptotes. This is one angle of asymptote. This is another angle of asymptote. Definitely, it will be extended this way. So these are the angle of four asymptotes. Angle of asymptotes. You have to draw in dotted line in the graph sheet, not like this. Or you have to use color. And you have to write asymptote. You have to write. Otherwise, you cannot distinguish between root locus and asymptote. So you have to draw the dotted lines. This is one asymptote. This is another asymptote. Third asymptote. And fourth asymptote. This is also asymptote. We have to find angle of departure because complex pole is there. Complex pole is there. That's why. So the root locus may come out and it will go like this. Another one will come out and go like this. Here, this will go like this, and this will go like this. Where it intersects the j omega axis, we can find. Where it intersects the j omega axis also, we can find. Now, let us find the angle of departure. So, to find the angle of departure, what are the poles? Let us find the angle of departure here. What are the poles? One pole at origin, another pole at -4. And one at here and another one here, 4 poles. So what is the angle of departure from P4? We have to find P1, P2, P3. Draw lines, angle of departure. Find angle of departure from P4 we have to find. To find that, we have to draw lines from P1, P3, and P4. So this angle is 90 degree, that we know. So this angle theta 1 we have to find. This is theta 2, theta 2. This is theta 3. Theta 3 equal to 90 degree. Theta 1 equal to what? What is P4? P4 is minus 1 plus J. From that you subtract 0. That is equal to minus 1 plus J. What is that angle? Minus 1 plus J. Polar coordinate, if you call, you will get automatically 135. Because this is 1, this is 1. Therefore, this is 45. Therefore, 180 minus 45 is 135. You will get 135 automatically. Got? Calci? 135. So, 135 degree. Theta 2 equal to what? Theta 2, this is 4. Theta 2 equal to angle of minus 4 plus J0 minus 1 plus J minus 4. That is equal to angle of minus 1 plus 4 equal to 3. 3 plus J. What is the angle? Angle of 3 plus J. Polar coordinate. How to call? Call shift polar function. You have to pass the parameters 3, 1. You will get the magnitude. You get the angle 3, 1, then equal, press equal, you will get the magnitude. Then to get the angle, you have to press what? In your calci to get the angle. It varies from, you have to see the manual. It varies from calci to calci. How much angle? 18.4. This angle, theta 2 equal to 18.4 degree centigrade. 4 degree. 18.4 degree. Theta 3 equal to 90 degree. Theta 3 equal to 90 degree. So all are from pole. That's why all negative. Therefore, pi P4 equal to 180 plus all these angles are 90 minus 90 minus 18.4 minus 135. 135. What is that net result? How much angle you got? Minus 63.4 degree. Minus 63.4 degree. Therefore, pi P3 equal to plus 63.4. So immediately we can write, because they are mirror image. Symmetrical about real axis. That's why immediately we can write pi P3 equal to 63.4. So now we can draw that where it intersect the negative, it come out at an angle minus 63. Minus 63 means it come out, we have to draw a line minus 63. Minus 63. This angle is minus 63.4 degree. Here we have to draw plus 63.4. So it come out at an angle this. So where it intersects the real axis, imaginary axis, we have to find. For that, we have to consider characteristic polynomial 1 plus g of s equal to 0. 1 plus k upon s multiplied by s plus 4, s square plus 2s plus 2. So that is equal to what? Characteristic polynomial is equal to 0, or s for k, s power 4 plus 6s cube, s power 4 plus 6 s cube 10s square plus 8s. 10s square plus 8s plus k equal to 0. This is the characteristic polynomial. So we have to write the Root array. We have to write Root array. S power 4, s cube. 1, 6, 10, 8, k. S square. 60 minus 8. 52 divided by 6. S square and k will come automatically here. S power 1 is k. Sorry. 52 by 6 multiplied by 8 minus 6k whole divided by 52 divided by 6. That is s power 1. S power 0 is k. So to find the k max, we have to equate s power 1 equal to 0. So that is 52 divided by 6 multiplied by 8 equal to 6k. Therefore, k equal to 52 multiplied by 8 divided by 36 equal to how much? K equal to 11.55 11.6 or 11.55. 11.55. K. You substitute in the second row. Substitute in the second row and find omega. 52 divided by 6 s square plus 11.55 equal to 0. Therefore, s square equal to minus 11.55 multiplied by 6 by 52. Therefore, s equal to plus or minus j, how much? 1.15. Therefore, 1.15 approximately equal to plus or minus j 1.2. So it cut at 1.2. At 1.2. So it intersect at 1.2 here. It intersect at here. Therefore, it come out like this. It come out like this and goes to infinity. And here also 1.2. 1.2 means here. Therefore, it come out like this. Here, this is the breakaway point. 3.1 is breakaway point. Therefore, it goes to infinity like this. This goes to infinity like this. That's all. Here, find the value of k so that the closed loop system, note down this part. Find the value of k. Find the value of k so that the closed loop system has a damping factor of zeta equal to 0.7. Zeta equal to 0.7. So it will go like this. It will be like this. This is constant zeta line. Constant zeta line. 0.7. 0.7 zeta line. It cuts here at A. Find the point A at the graph sheet. Join all poles from that A. Find the magnitude. Yesterday I told you how to find the magnitude without using scale. Call the polar function. Call the polar function. Suppose A is, let us assume that A equal to, it is less than this and less than this. 0.8 plus j 0.8. Let us assume 0.8 plus j 0.8. How to find magnitude from all poles A to all poles? We have to find AP1, AP2, AP3, and AP4. If you multiply all these, you will get K. AP1 equal to what? Modulus of 0.8 plus j 0.8. Don't use this 0.8. Typical value. I am not drawing exact. You would find in your graph sheet. Minus modulus of 0.8 plus 0.8 minus, what is P1? 0. 0. That's all. Modulus of this you have to find. Next one is 0.8 plus j 0.8. Second, minus of 1 minus j plus j. Modulus. Modulus means you have to call the polar. You have to find the magnitude. AP3 equal to 0.8 plus j 0.8 minus -1 minus j. Then P4 is 0.8 plus j 0.8 minus of -4. That's all. So I wrote P1. This is P1, I think so. This is P1. This is P2. This is P1. P2, P3, P4. So by calling that polar function, you can find the magnitude and multiply. Therefore, K equal to what? K equal to AP1 multiplied by AP2 multiplied by AP3 multiplied by AP4 divided by 1, because no zeros are there. This is the K value for zeta equal to 0.7. So here zeta 0.7 line will go like this. It cuts here. This is A.